Okay, since this is a calculator problem, I'm going to take the dangerous step of zooming in on it, and then we'll put your calculator here so we can see how you work it.
Okay.
But whenever I do this, I forget to zoom out, so remind me to zoom out for the next video. This is a calculator problem you got wrong. The fuel consumption of a car in miles per gallon is modeled by f of s equals 6 e to the s over 20 minus s squared over 2,400, where s is the speed of the car in miles per hour. If the car is traveling at 50 miles per hour and its speed is changing at a rate of 20 miles per hour squared, at what rate is the fuel consumption changing? Alright, so this one you actually left blank.
Alright.
Okay, so what are we going to do here?
Well, so we have a function for the fuel consumption.
Okay, so that's f of s equals 6 e to the s over 20 minus s squared over 2,400. I'll put this on camera. Not really. Zoom out. Okay.
And we know that s starts off at 50.
Okay, so s starts off at 50 miles per hour. The car's traveling 50 miles per hour, so s equals 50.
And then we know...
Its speed is changing at 20 miles per hour.
So s prime is 20.
Okay, so yeah, ds dt is 20.
So what rate is the fuel consumption changing? So we're going to need to take the derivative of this expression.
Okay.
Where at s equals 50.
Okay. So what are you going to do?
So I don't know if it's visible on the calculator, but there's just a button that lets you find the derivative at a point.
Oh, okay. So you're going to do it the whole thing in a calculator here. So I'm going to put the calculator right there.
Alright. So yeah, this is our derivative button, so it only lets me use x, so d dx of 6 times e to the, use a couple parentheses, x over 20 minus x squared over 2,400, and then our initial x value is 50. So we have 0.2149. All the choices are rounded.
Okay.
So that's choice A,
Alright.
0.215.
Okay. So is that your answer?
Well, not quite, because we have to multiply this 0. Okay.
Alright, let me zoom out.
We have to multiply our 0.215 about by an expression for s prime because of our chain rule.
Okay.
I think. Yeah. No, we did that. Well, I'm not sure that we did, but this is the smallest choice, and our chain rule, our other expression would be 1/20th minus s over 1,200.
Okay.
Which is super small.
Alright.
So I think this already did that, so I think this is our answer.
Okay. Yeah, so that unfortunately is wrong. But it's interesting that they were able to anticipate that mistake. So what you found was ds. You found df ds. You found how f changed with s. And so what do you need to find?
We wanted to find df dt.
Right. So what do you need to multiply?
So you need to multiply this by ds dt.
ds dt. Okay.
Which is 20.
Just 20. So The actual answer is that 0.214. Do times 20.
which is about 4.299.
Yeah, right there, 4.299. So you do have to be careful. So you found the derivative of the function with respect to s, which is what your calculator can tell you, but s is also changing in time, and so then you have that extra ds dt. So, okay, good. All right, next problem.